Welcome, ladies and gentlemen. So what I'd like to do is show you how to solve and graph one-step inequalities. Now, basically one-step inequalities you can think of just like one-step equations, because exactly the solving is going to be exactly the same. The only really difference that we're going to do is instead of just saying, you know, like an equation, x equals 2 is our solution. When we say x is greater than 2 or x is less than or equal to 2, we're going to have to graph the solution. We're going to use a number line, which I'll show you how to do. The only other thing, too, is also to remember that when you multiply or divide by a negative number, which I'm not going to do an example in this video, but when you multiply or divide by a negative number, then you have to make sure you flip the sign. So in two-step and multi-steps, we'll go over that. But in this one, we're just going to practice again using our inverse operations to help us solve. So therefore, we can go from there. So again, the main important thing when solving an inequality, just like solving an equation, think of the inequality as an equation. In some videos, I've even shown to like replace it as an equation, because basically you're just going to use the same inverse operations. Don't let the inequality symbol change that or make you, get confused. So basically what we want to do is we want to isolate our x. So therefore, we need to identify what operations are happening to our x that we need to undo. So you can see here my x is being added by 6. So to undo adding by 6, I am going to subtract a 6 on both sides. So when doing that, now that adds to 0. So I'm left with x is greater than 4. Now I need to go ahead and graph this. So what I'm going to do is I'm going to create a number line. And in the middle of my number line, I'm going to use my solution, which was 4. Then I'm just going to create some tick marks here to the right and to the left. Now, values going to the right are going to be larger, and values to the left are going to be smaller. What the heck did I do here? So again, one of the common mistakes is students always want to include 0 in the middle. Don't need to, don't have to. What if my solution was 40? You wouldn't want to start at 0 and go all the way over to 40. Or what if it was 400? So I always like to start with my solution in there. Now, the next thing, just like we were practicing graphing inequalities, I always like to take my solution here and make a nice big point right there. Then we notice that x is greater than 4. So if you kind of forget, should it be open or should it be closed, go back to always using a test point. Plug 4 in for x. Is 4 greater than 4? No, 4 is equal to 4. So therefore, that's false. So therefore, that's going to be an open circle. Then if you kind of forget, which way should I graph? Should I graph to the right or should I graph to the left? Pick points on the right or the left and plug them in for x. So I could say 7 is greater than 4 or 1 is greater than 4. And we're going to graph to where the points are always going to be true. And if it's true on one side, if one point's true, that means all the rest of the points are true. So is 7 greater than 4? True. Is 1 greater than 4? False. That means if this is true, all the points are true. And let's look at it. Is 5 greater than 4? Yes. 6 greater than 4? Yes. So therefore, I'm going to do a nice little squiggly line to represent all the points, and then represent an arrow that's going to say, as long as I keep on going to the right, all those values are going to be greater than 4. So that's the long way how to graph, but I figured I'd at least go over it once so you can always go back to it. All right. So now let's go and look at, go over to the next example here, which I have x plus 2 is less than or equal to negative 5. Again, applying our inverse operations here. You can see my x is being subtracted by 2, so I'm going to undo that by adding 2. Therefore, now I have x is less than or equal to a negative 3. OK, so now I just need to go ahead and graph. So again, we create our number line here. And now I'm going to use negative 3 in the center. Remember, values to the right are going to be more positive, so that would be negative 2, negative 1, 0. To the left are going to be negative, or smaller numbers, negative 4, and negative 5. Now again, we make a nice big circle here. Now hopefully you remember, oh yeah, whenever it's greater than or less than, it's open. Whenever it's less than or equal to or greater than or equal to, it's closed. And I'll just use a test point again, just for the last one, just to kind of show you. Again, if you plug that in, negative 3 is less than or equal to negative 3. Is negative 3 less than negative 3? No. Is it less than or equal to? Yes, it's equal to, right? So since that's true, whenever you see that less than or equal to, that didn't work out really well. That's supposed to be closed point. Hopefully that looks that way. Let me just try a different marker here real quick. There we go, nice and dark. Okay, so then the other kind of case is now it's just saying what values are less than -3. Well, you can see that, as we're going over to the right, we're going to start getting into positive numbers. Well, positive numbers are not less than -3. It's going to be all the numbers to the left are going to be less than -3. Again, you can use test points if you like to. And since my variable is on the left-hand side, you can also see the arrow is going to be pointing to where the solutions are going to be. Then just make sure you include this arrow representing that as long as I keep on going to the left, all the values are going to be less than -3. And the point -3 is less than or equal to, so that's included. So now we get into our next inverse operation. We have x is being now multiplied by 3. So again, what we do to undo multiplication is divide. So therefore, that divides to 1, so I'm left with x is less than 6. Again, ladies and gentlemen, you can notice that this is less than. So therefore, just like less than and greater than, it's going to be an open circle. So let's go and create our number line here. So I'll start at 6. To the right is going to be more positive values. To the left is going to be getting smaller. Then I'll make sure I put a nice circle here. OK, now what values are less than 6? What values are smaller than 6? To the left or to the right? You can see, obviously, that the point's to the left. And again, if you get confused, just use test points. All right. Last one. Now, this one is the one that gets students all the time. And I try to keep these problems simple for a reason. If x is being added to 6, you subtract. If x is being subtracted by 2, or being subtracted, you add. If x is being multiplied, you divide. If x is being divided, you have to multiply. So therefore, my inverse operation on this is I'm going to multiply by 5 on both sides. By doing that, that again divides to 1, just like how this divided to 1. That divides to 1 as well. Man, I'm losing all my blacks. So therefore, I'm now left with x is greater than or equal to -5. Now, let's go ahead and graph that. So again, we create our number line here. Start at -5. To the right is going to get larger numbers, so that'd be -4, -3, -2. To the left is going to be smaller, -7, -8. A lot of students get confused on this, like, what do you mean, how's it smaller? Their numbers are larger. Yeah, the absolute value of the number is larger, but think about negatives as like owing money. So here, let's say you owe money is -$5. If you owe me -$8, you have less money, right? These numbers are smaller. If you only owe me -$2, you technically have more money, right? More money, so these are going to be larger. All right, so again, we just go ahead. Yeah, I'm dropping markers left and right. Make our circle. That's greater than or equal to, so that's going to be a closed point. Again, these are saying x is greater than or equal to -5. What are the values that are greater than? Arrows pointing to the right. X variable is on the left-hand side. So I can just follow that. Make sure you include the arrows. See how I included the arrows for all these? Students forget it all the time, and I mark them down. These points are continually going right. That's what's so important about graphing inequalities. So there you go, ladies and gentlemen. That is how you solve one-step inequalities and graph the solution. Thanks.